How can we write Typesafe SQL queries in Bun? There's a query builder called Kysely, which makes writing Typesafe SQL queries easy. And importantly, it doesn't add a lot of runtime overhead to your application. In this video we will explore Kysely with Bun in a demo application. But first let's clarify what Kysely actually is. Kysely is a Typesafe SQL query builder for TypeScript. It does only one thing very well. It generates SQL queries according to your dialect. If you know SQL, using Kysely will be very straightforward. Kysely's type safety allows us to spot errors at compile time, which would normally occur only during execution time. Those errors are typically schema or syntax related. And because Kysely understands our schema, we have a great auto-completion when creating our queries. With this in mind, let's directly dive in and see it in action. Let's first set up our project with Bun. The command bun init lets us directly start our project with TypeScript. So let's now install Kysely. In this demo we will use SQLite, so let's install the Kysely Bun worker dialect. It generally makes sense to run your SQLite access within a worker or a separate process, because SQLite queries will block your main thread. And this is what we want to avoid at all costs when running JavaScript on the server. So let's quickly copy this command and install our Kysely Bun worker package. Okay, let's now create our Kysely instance. For this we first create our dialect. If we don't configure this dialect, it will by default create an in-memory database for us. This is sufficient for our use case. Let's now finally create our Kysely instance. Now we are ready to go to execute SQL queries. When using SQLite, we have to turn on foreign keys if we want to use them. Let's do this first. Kysely provides us with an SQL template literal function, which we can use to execute raw SQL queries. Let's use this to enable our foreign keys. The query will be executed within our Kysely instance, and we want to await the resulting promise here. Now it's time to create our database schema. Kysely allows us to write migrations within TypeScript, so let's use this example and modify it to our needs. But before we write our actual migrations, let's quickly define our target schema as TypeScript definitions. In this demo we will create basic blog posts and comments to those blog posts. So let's create the necessary types for this. Our demo blog post will simply have an ID and a title. The ID will be automatically generated by SQLite. We can use the generated type from Kysely to indicate this. A comment will also have an ID, a post ID, referencing the blog post, and a text. Those are our basic database types. Let's now create a schema type which Kysely understands. It maps the table names to the interfaces we just created. It also makes sense to define some types for selecting, creating and updating our database records. For this, Kysely provides some extra types. The blog post type is exactly the type that Kysely provides us when we select all columns from this table. The new blog post type defines what we can insert into the blog post table. When we want to update a record in the blog post table, we can use a partial type of the blog post table, which is defined by this blog post update type. Let's quickly do the same for our comments. Okay, let's now create our migration according to our defined schema. All the DDL statements are located under the schema property on our DB instance. We want to call our table blog post, which we defined over here in our schema. Our first column will be the ID column, which is an integer. And we want this to be our primary key column. This is auto-incremented in SQLite. We can use a third parameter to define our column constraints. Now we want to add our title, which is just another column of type text. By default, the column is nullable, but we want this to be required, so let's add the necessary constraint for this. Finally, we can execute this query and await it before executing the next query. So let's now create our comment table. We have an ID, and we want to reference a post. And we have a non-nullable text column. Let's execute this. This schema definition should exactly match our schema that we defined in TypeScript. If you already have a database in place, it may make sense to have a look at generating types in the Kysely documentation. There are multiple ways to generate your Kysely schema types from an existing database or Prisma, for example. But in this basic case, we write our schema from scratch. To have a complete migration module, let's implement the down migration as well. It's very simple. We just drop the two tables we just created. Of course, we should first drop the comments table because it has a foreign key to the blog posts table. Let's now create our migration provider. To write our migration provider, we have the migration provider interface exposed by Kysely. We only have to implement one method, getMigrations. This has to be asynchronous. And let's just import our migration modules here. The named migrations within this object will be executed in lexical order. To run our migrations, let's create a migrator from Kysely and provide it our database and the migration provider. and we simply migrate to the latest version. Let's now create our data access layer for our blog posts. We will write some bun tests to verify that our data access actually works as expected. Let's first create a blog post. We also have to provide our schema to the Kysely instance for the autocompletion. In SQLite, we have to fetch the last insert ID In SQLite it's a bit tricky to get the last insert row ID. Let's create a separate function for this. And let's move this to a central location, for example, within our database here. Let's now import it over here and create our first blog post. Let's now actually execute this test. We see that this test passes, but let's verify that the data is actually stored in the database. We want to test the members within our block data source, and we don't want to test Kysely itself here, so let's simply use Kysely to retrieve our records. Okay, we don't want to expect a specific ID here. We want to verify that this ID was generated automatically. So let's just check whether it's a number. For verification, it often makes sense to select all blog posts, and let's create a function for this. This was the creation of a blog post. Let's now implement selecting a blog post. This is one thing we don't want to do in our tests. We don't want test dependencies. If create post doesn't work correctly, this would also fail. So let's create a function in our test module which will create a post. Let's retrieve the post ID here. Let's now implement this. And import it over here. Now our tests pass again. We will skip the update part here and introduce comments instead. Let's now implement our create comment function in our module. And import it in our test. This works well. Now it might be interesting to count all the comments that are attached to one blog post. Copilot does a good job when generating some tests. Let's now implement the function. So we select from blog post. Then we use an inner join to join the comments. That looks good. Then we do a select. Here we can use a callback function to create our columns. We have the functions placed in an fn object. This way we can type safely create a count select statement. We also should give it a number here as generic. Now we have to group by the blog post ID and execute the query. The invert return type of this function seems to match what we want to achieve. So let's now import this function here and rerun the test. Here we see that we have one post more than we are expecting. Why this? Let's run this test in isolation. And it passes. So we have a test dependency within this suite. The test dependency is created by writing multiple records to the database and not removing them again. So let's truncate our tables before each test. Now we see that our tests are passing. We covered quite some ground in this video, but there's much more to learn about Kysely if you want to really use it in your projects. If you're serious about learning Kysely, I strongly recommend to have a look at the documentation. There are plenty of examples and recipes in here that you can refer to get your first queries running. I can also recommend using the playground to see how your query that you built with Kysely translates to SQL. If you are unsure whether you want to use Kysely or another tool to query SQL databases in TypeScript, I created a video for you where I compare the various approaches to query SQL databases. You can find it over here. And here is another video that could be interesting for you. In this sense, never stop learning, and see you in the next video.